Okay, section 3.3, objectives 4 and 5. We did part of objective 4 in 3.2. 3.3 has converses of the postulate and theorem that we did in 3.2, plus 2 more theorems. We are going to skip the warm-up because this is a long packet. If we have time, we do it in the class, okay? All right, so we're here. After this, we're going to practice more proofs, and then we have a quiz. Okay, so objective 4, state and apply the postulate and theorems about parallel lines. 3.3 converses. 3.2 was conditional. Okay? All right, so here is the postulate 10 that we did in 3.2. If two parallel lines are cut by transversal, then corresponding angles are congruent. And the postulate 11, this is in 3.3. If two lines are cut by transversal and corresponding angles are congruent, then the lines are parallel. Okay, so these, the theorem 3.5, theorem 3.6, and theorem 3.7 are all converses of the theorems that we learned in 3.2. And these we can use to prove lines parallel. Okay, so here is the theorem 3.5. If two lines are cut by transversal and alternate interior angles are congruent, then lines are parallel. Okay, transversal. And you want to prove that two lines are parallel. That's what you're trying to get to. Okay, so here is the steps. Okay, so this is given, right? I want you to do this. Now remember, these are congruent marks, right? So things that you can say here are limited. Okay, fill this out. Homework. Here is theorem 6.3. So this is the same side interior one. If two lines are cut by transversal and, let's just see here. Is that better? If two lines are cut by transversal and same side interior angles are supplementary, then lines are parallel. Okay, so this one, again, this one I'm going to give you the statements and you do reasons, okay? So line 1, angle 1 and angle 2 are supplementary. Okay, number 2, measure of angle 1 plus measure of angle 2 equal 180. Number 3, measure of angle 2 plus measure of angle 3 equal 180. Line number 4, measure of angle 1 plus measure of angle 2 equal measure of angle 2 plus measure of angle 3. Number 5, measure of angle 2 equal measure of angle 2. 6, measure of angle 1 equal measure of angle 3. And 7, K is perpendicular to N. Okay, so you supply the reason for these 7 lines. Okay, and theorem number 3.7. In the plane, two lines perpendicular to the same lines are parallel. In the plane, you remember, if it's a 3D, they can all be perpendicular, right? But in the plane, the two lines perpendicular to the same line are parallel. Okay, so again, I'm going to give you the statements and you do the reasons. Okay, 1, K is perpendicular to T, N is perpendicular to T. 2, measure of angle 1 equal 90, measure of angle 2 equal 90. 3, measure of angle 1 equal measure of angle 2. 4, K is parallel to N. Okay, So you do the homework. So these are homework. Okay. All right, so let's do this one and this one as well. All right, which segments are parallel? So these, let's check these two lines first. Okay, so these are corresponding angles, but this is 61 and 62. So these are not the same. These are corresponding angles, not the same. So WI is not parallel to AN. So let's check HI and TN. So this angle will be the angle that we should be looking at, right? Corresponding angle, if these are the lines and this is a transversal. 61 plus 23 is 84. 62 plus 22 is 84, so these are parallel. Okay. All right. Find the value of x and y that make AC parallel to DF and AE parallel to BF. So you want to make these parallel and these parallel. Okay. So that means that these are same side interior angles with these two lines and this transversal. So this I'd have to add up to 180. And these two angles are alternate interior angles with these two lines and this transversal. So they have to equal. Okay? So you do this one for homework. Okay? And this one I want you to do odds. This page. Okay? This page. So you're doing 1, 3, 5, 7, 9, and 11. Okay? Right, objective number 5. State and apply the theorems about a parallel and a perpendicular to a given line through a point outside the line. Okay? State and apply the theorems about a parallel and a perpendicular to a given line point outside of a line. So through a point outside a line, there is exactly one line parallel to the given line. So here's a line, and there's a point outside of the line. Then the line that is parallel to this line, there is only one. Okay, so that's theorem 3.8. The theorem 3.9 is here's a line and a point outside the line. Through this point, there is only one line that is perpendicular to this line. Okay, and these theorems can be proven with postulates and theorems we have learned, but we are going to use these without proving these theorems. It's going to be a little bit too long, and then it's outside of scope of this curriculum, so we just accept this without showing you a proof. I think the proofs are in the textbook somewhere if you're interested. Okay. All right. So, in theorem 3.10, two lines parallel to a third line are parallel to each other. This one we're going to prove. Okay? All right, so let's do this one. You can probably do the reasons. Okay, so K is parallel to L and K is parallel to N. Now we're going to use this diagram, okay, because we need to do these angles. So if this is a diagram, you draw a line T transversal and you name the angles. Okay, all right, so 2 measure of angle 1 equal measure of angle 2. 3 measure of angle 1 equal measure of angle 3. 4 measure of angle 2 equal measure of angle 3. And 5, L is parallel to N. Okay, think you can do the reason here. Okay. All right, so here's a summary. Ways to prove two lines parallel. Show that pair of corresponding angles are congruent. Show that pair of alternate interior angles are congruent. Show that a pair of same-side interior angles are supplementary. In the plane, show that both lines are perpendicular to a third line. Show that both lines are parallel to a third line. If you do any of these are, so this was the postulate, right? And these are all theorems that we just did. Okay. We proven all this. The only one that we didn't prove are the lines out point outside the line ones. Okay. Practice for objective 5. Okay. How many? All right. So I want you to do odds here for homework. And let's do evens here. Okay. How many lines can be drawn through P parallel to QR? So that's just one, right? How many lines can be drawn through P perpendicular to QR? Again, by the theorem, it's just one. I'm sorry, the 16 is 1. 18. In space, how many lines can be drawn through R perpendicular to OR? Wait, QR. In the space, so not in the plane, but in the space. How many lines can be drawn through R perpendicular to QR? So it's infinite. Because any lines that go through here and in this angle, you can just draw infinite number that is 90 degrees to this, right? If it's a plane is perpendicular to this line, any lines that are on the plane going through R would be perpendicular, so it's infinite. Okay, so you do the odds here, and the rest are for the classroom exercises. So we are done. Okay, see you in the class. Don't forget to do the survey.